Here we go. So today what we're talking about is rationalizing. Write this down. Rationalizing the denominator. What in the heck does that mean? In English, it means getting rid of square roots in the bottom. Okay, that's pretty much just non-math words. So the whole idea is rationalizing. So square roots are irrational numbers. They're irrational because they're ugly numbers. Okay, square root of 5 is an irrational number. Okay, so I want you to watch. Okay. Square root of 5. It is a 2.236066797. It is an irrational number, okay? It's an irrational number. So what we want to do is make it a rational number, like 5 or like 6 or whatever, a normal number. Not an ugly. So we're going to rationalize the denominator, which is basically making the bottom part of the fraction have a regular integer number. So how do we do it? So we're going to do this. So if I take a look at example 1, I have a square root of 5 in the bottom. That's the problem. I can't have, the rule is you can't have, so my rule is can't have a square root in the denominator, bottom. Okay, that's our rule. Okay, can't have a square root in the denominator, okay? Luke.
So why can't you have it on the bottom but you could have it on top?
Great. So when we divide, if we have to do any dividing, like there might be something up above that we could divide, we'd be able to divide a regular number into a regular number, okay? Good question. Chase.
Would you just multiply top and the bottom by the square root of 5?
Very good. Wow. So here, I'm gonna phrase it differently. Yes. Here's what I'm gonna say. So the problem is, if you listen to it, it's really easy. The problem is the square root of 5, right? So we fix the problem with the problem. I'm gonna say it again. We fix the problem with the problem. I write that down. So we fix the problem with the problem. Okay?
That's my life.
We fix the problem with the problem. Okay? Now, what does that mean? Chase, you said it actually. You nailed it perfectly. Okay? So here's what I'm going to do. The problem is the square root of 5. So I fix the problem with the problem. So watch. I'm going to multiply top and bottom by the square root of 5 over the square root of 5. How's that going to help? Well, yeah. So if you fix the problem with the bottom, square root of 5 times square root of 5 is the square root of 25, right? And that's just 5. Now at the top we'd have a 3 square roots of 5, but watch what happens on the bottom. Square root of 5 times square root of 5 is square root of 25, right? But the square root of 25 is a great number. It's not an irrational number. It's just a plain old 5. So we get 3 square roots of 5 over 5. There is no longer a square root in the bottom, is there? Don't divide these. That is not 5. That is not a 5. Don't divide these. That's a 2.24. That's an ugly number, okay? That's it. So we took a problem that had a square at the bottom, and we changed it so that it does not have a square at the bottom, okay? Okay, so I multiplied just by square root of 5 over square root of 5. Gives me a 3 square roots of 5 over, and the whole reason it works is because I get the square root of 25 here, which makes it a regular old 5. Okay, let me slide over to number 2, okay? Let's do the same thing. So before I do it, though, let's rewrite this. It really is like the square root of 5 over the square root of 7. Let's write it as a top part and a bottom part of the fraction. Okay, now, what's the problem? It's the square root of 7, isn't it? Can't have this. Can't have a square at the bottom. So let's fix the problem with the problem. So I'm just going to multiply top and bottom by the square root of 7 over the square root of 7. Okay, how's that going to help me? Well, I'm going to get a square root of 35 over the square root of 49, right? Because 7 times 7 is 49. The square root of 49 is a great number. It's just plain old 7.
Where did you get 35 again?
5 times 7. Good question, Holly. So square root of 49 is plain old 7. But then on the top, we get the square root of 35. And a square root on the top is okay. It really is okay. You just can't have square root on the bottom, okay? Don't divide. Don't divide these because this is really not a 35.
So divide the bottom?
So no, we have to leave it right here. This is my answer.
No, I mean the step before. So with the 49, you just divide that by.
I just square rooted it.
Oh, yeah. Sorry.
No, it's okay. It's all right. Okay, now, example 3. Same thing. What am I going to do? What am I going to do?
Fix problem with problem.
Great. And what's our problem in example 3? Make it quick. Square root of 5. So let's go ahead and multiply by the square root of 5 over the square root of 5, right? So I wind up with, on top, or the numerator, I get 6 square roots of 5. And the denominator, we get the square root of 25. And I wanted to do that because there is a square root of 25, right? It's plain old 5. So you wind up with 6 square roots of 5 over 5, okay? Because square root of 25 is 5. And now, we don't have a square root at the bottom, do we? Looks pretty good. Don't divide those 5s because that's not really a 5. It's not a 5 at all. It's an ugly number, okay? Yeah, Kobe?
So why did you make it a 6 square root of 5 instead of just multiplying together?
Awesome. Good question. That is not a square root number, okay? So square roots go with square roots.
Okay.
Good question, okay? Now, example 4.
There's no problem.
There's no problem. Nice job, Giselle. Nice job. So you could do some work, but watch this. What is square root of 4?
2.
Just do it. It was easy. It didn't trick Giselle at all, right? It was meant to try and trick somebody, but it didn't trick you, did it? It's plain old 2. That's fine. Nothing wrong with that problem, is there? Now, example 5. Don't do anything. Just watch. It's a different kind of problem, okay? Now, just watch. If I multiply by square root of 3 over square root of 3, it's not going to work, but I'm going to show you, okay? So I'm going to break the rule. I'm going to show you, okay? Because you thought it was easy, right? Okay? Square root of 3, square root of 3, okay? I get 5 square roots of 3, and on the bottom, I'm going to get 7 square roots of 3 minus the square root of 9, right? Just don't write this down, just watch. Just went this times this times this, right? Okay, then I'm going to get 5 square roots of 3 on the top, and on the bottom I get 7 square roots of 3 minus 3. I still have a square root on the bottom. It didn't work. So when I get a plus or minus in here, I'm going to multiply it by its conjugate. If there's a plus or minus here, I'm going to multiply it by its conjugate. So let me show you how I want you to do these. These are different. So if you get a plus or minus in the bottom, we do it differently, okay? If you got a number minus a number or a number plus a number, we're going to do it differently. What are we going to do? We're going to multiply it by a thing called the conjugate. Let me write that down. So the conjugate, what the heck is the conjugate?
Isn't the conjugate?
It's the opposite. It's going to be the opposite. So the conjugate of this one is going to be 7 plus the square root of 3. Okay, the conjugate is the opposite of this. And let me show you how it works, okay? So if it's a plus or minus, I'm going to multiply it by 7 plus the square root of 3, okay? Just the opposite. So I'm going to multiply both top and bottom by 7 plus the square root of 3, 7 plus the square root of 3. And I'm going to show you why it works, okay? So if you get the plus or minus in the problem on the bottom, I've got a number minus the square root of 3. And in the back, I'll show you another one in the back, I've got a plus. So I'm going to do the opposite. That'll be a minus on the back. But we'll do that in a sec, okay? So now, how does this work? Okay, so check it out. This is going to work, but you gotta be faithful and watch, okay? So let's do the top first, because the top's not too hard, okay? Ready? 35. See the 35? See the 35? 5 times 7 is 35. 5 times the square root of 3 is a positive 5 square root of 3. And Kobe, I won't multiply those, right? Because that was your question, Kobe, remember? Because that's a regular 5 and that's a square, so we don't multiply them, okay? Now on the bottom, let's FOIL. 7 times 7 is 49. 7 times a positive square root of 3 is a positive 7 square root of 3. Okay? Let's keep going. Negative square root of 3 and 7 is a negative 7 square root of 3. And negative square root of 3 times negative square root of 3 is a negative square root of 9. Want me to show you that again? I'll do it again. 7 times 7, 49. 7 times positive square root of 3 is a positive 7 square root of 3. 7 times a negative square root of 3 is a negative square root of 3. Negative 7 square root of 3. And then negative square root of 3 times positive square root of 3 is a negative square root of 9. Now the reason we did the conjugate is because it made opposites. By doing the opposite sign, guess what? We made opposites. And watch what happens. Cancel, cancel, right? Square roots are disappearing on the bottom, aren't they? Now what about this 9? What's the square root of 9?
3.
All your square roots gone, aren't they? This becomes 3. And before I finish it,
Is it a negative 3?
yes. Are there any square roots on the bottom?
No.
They're gone. So my answer is going to be 35 plus 5 square roots of 3 over 46. How do I get the 46?
49 minus 2.
49 minus 3. No square roots on the bottom. No square roots on the bottom, okay? Okay, ready to turn the page? Okay, so, example 6. Alright, now, fix the problem with problem. Okay, this is not one of those weird ones, right? There's no plus minus. There's no conjugate. However, before you multiply by the square root of 50, square root of 50, that's a pretty big number. Let's do a little bit of reducing. Nice job, Giselle. So Giselle, here's what Giselle saw. The square root of 50 can be the 25 and 2. I'm just going to make it smaller, so my number's smaller. So that becomes the square root of 3 over 5 square root of 2. Now, the problem is the 2, not the 50, because we reduced 50, so we got a smaller number. If I do the whole reducing thing, we got a smaller number, so we still have to fix it. But we only have to fix it with the 2, not with a 50, but with a 2, right? So multiply top and bottom by the square root of 2, square root of 2, okay? Not 50, because we reduced it. Nice job, Giselle. So I wind up with a square root of 6 over 5 times the square root of 4.
The square root of 4 is 2.
Square root of 4 is 2. 5 times 2 is 10. 10's on the bottom. Square root of 6 is on the top. Don't reduce this. That's not really a 6. Don't reduce this. This is not really a 6, okay? It's an ugly decimal, right? It's an ugly number. Okay? Thumbs up? Okay, how about example 7? What's the problem?
3x.
So the x is part of the problem. You guys agree?
Yeah.
So fix the problem with the problem. Well, the x is part of the problem, so let's just let's go square root of 3x, square root of 3x, okay? Because the x is part of the problem, so fix the problem with the problem, okay? So what am I left with? 5 times the square root of 3x over the square root of 9x squared, okay? Take a look at it. Take a look at it. I've got my 5 square root of 3x, and on the bottom I've got my square root of 9x squared. But I can take the square root of both of those, right? So the square root of 9 is 3, and if I take half my exponent, I get just x to the 1. I don't need the 1, but I'll put it there anyway, okay? So, the square root's cleared. It's cleared. No more square roots. But on top, I still have 5 square roots of 3x, okay? Don't divide those because it's not really an x. It's a square root of x, okay? Don't divide the 3's because it's not really a 3. It's a 1.73 blah, 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 okay? Stop there, okay? Now, example 8. You got the plus, right? You got the plus. So we're going to need our conjugate, okay? So our conjugate is the opposite of this. So I'm going to multiply top and bottom by 2 square roots of 3 minus 3 square roots of 5. I'm going to multiply by 2 square roots of 3 minus 3 square roots of 5. So top and bottom, we're going to multiply by 2 square roots of 3 minus 3 square roots of 5. Okay? Top and bottom. By the opposite. 2 square roots of 3 minus,
Why is it finding zeros?
huh?
Why is it called finding zeros?
Where?
This isn't good for you.
Oh, I'm a day off. I'm a day off. I lost my prep this morning. Doggone it. Mr. Daly took it away from me. I'm putting this on film, right? But I got to work out for free.
There we go.
Yeah,
But I
that's right.
didn't get a chance to buy. I got to work out for free, but I did not get to prepare for class. So anyway, here we go.
Hey, gains are more important than...
Here you go.
It's more important.
Okay, you ready? So here we go. This times this. This times this. You guys okay with that? Let's do that first. 10 square roots of 3. You guys see 10 square roots of 3? 10 square roots of 3. Minus 15 square roots of 5. You guys see 15 square roots of 5? Minus 15 square roots of 5. Okay, now on the bottom, we're going to have to FOIL. Okay. 4 square roots of 9. You guys see 4 square roots of 9? 4 square roots of 9. Minus 6 square roots of 15. Minus 6 square roots of 15. Plus 6 square roots of 15. That will always happen. That's why we do the conjugate. The whole reason we're doing it is this will always happen. Plus 6 square roots of 15. By doing the conjugate, you make the opposite, right? And then probably minus 9 square roots of 25. Okay, now our square root's going to drop out of the bottom. All our square root's going to drop out of the bottom because these two are opposites. That's always going to happen with the conjugate. Always happens with the conjugate. And then square root of 25 is 5. So, and the square root of 9 is? So let's see what we got. I got 10 square roots of 3 minus 15 square roots of 5 over 12. You guys see 12? See my 12? Minus 45. 12 minus 45, what's that, a negative 33? And on the top, the numerator, I get 10 square roots of 3 minus 15 square roots of 5. Square roots on the bottom? Nope, it's gone, right? No more. Okay, that's it. Now,